In this video, we're going to talk about the midpoint and distance formula, which adds some algebra, but it's very useful when we're trying to find lengths and midpoints, which we do a lot in geometry. So your objective is that you can find the midpoint between two coordinates, so we're talking about xy coordinates. So we're looking at our coordinate plane again, and find the distance between two coordinates, again xy. So remember a midpoint. The midpoint is the middle of a segment, or divides the segment into two congruent parts. So if I would put the midpoint on this segment, that means this part is the same length as this part, so we use our tick marks. So this is 4, and that is 4. Here I have x. So if I want to find the length here, I divide x by 2, so that's x over 2. And then this is also x divided by 2. On this segment, if I find the midpoint, my whole segment is 15, 7.5, 7.5. So midpoint is middle. Alright, so the midpoint formula, I'm going to show you a little bit of where it comes from. If I give you 2 points, so the points I have here, looks like we have 5, 3, and I have the point -2, -1. So in between these points, there's an invisible segment that we're going to draw in there. And somewhere on here is the middle. And I want the exact coordinates. I want to know where is this midpoint located. Well, if you think about it, you can draw a right triangle. We're trying to find the middle. This one is parallel to the x-axis, so this is your x, and this is your y. So I want to find the middle of my x. So this length is 1, 2, 3, 4, 5, 6, 7 long. So halfway would be 3.5, 1, 2, 3 and a half. There's my midpoint. And then here, this length is 1, 2, 3, 4, so halfway, this would be the middle. Well, where these two little segments come together makes the middle of my segment here, and then I can find the coordinates. So what you're actually doing is you're finding the average x coordinate and then the average y coordinate. So therefore, you get a midpoint formula that looks like this. You're adding your x's and dividing by 2, because I have two numbers and I'm dividing by 2, and find two numbers and divide by 2. So this is, again, it's your average. Average of your y's, average of the x's. Middle x's, middle y's. And if I would plug this in, so we get my two x's, which is 5 plus -2, and divide that by 2, and I get -1 plus 3, and divide that by 2, I get 1.5, because this is 3, this is 2, and 1. My midpoint of this segment is located at the coordinate 1.5, 1. Midpoint is always a coordinate. Students sometimes just like to leave out the parentheses, but for it to be a coordinate, it needs those parentheses. Alright, so let's practice finding some midpoints. So we have the point 1, -3, and 4, 2. And if I want to find the midpoint, again, I average my x's. So I go 1 plus 4, divide by 2, and -3 plus 2, and divide by 2. That's 5. Divided by 2 is 2.5. And that's -1. -1 divided by 2 is -0.5. So I'm going to plot that point between these 2 points and see if my answer makes sense. Again, one thing you have to become really good at, and just this in like any kind of job you go into, is always check back, like, okay, I got an answer, but does that really look like what it is? Alright, so we have 2.5 and 0.5, which looks like it's on our segment, and it does look like it's the midpoint. Alright, so let's erase that and let's do B. Practice one more. This is also a good time to pause the video and see if you can figure it out for yourself. Ask yourself, does my answer make sense? Check it, and then you can run the video and see if you got the same answer as I do. Alright, so we have 2, 1 as your first point. That is M. And then 1, 4. So we have this segment here. So I need to find the midpoint between those two segments. So I add my x's. I add my y's. That's 3 divided by 2, which is 1.5. 5 divided by 2, which is 2.5, or 2.5 if you like fractions. Alright, so I'm going to plot that point and see if it makes sense. 1.5, 2.5 is on my segment, and it looks like it's in the middle. So that is the midpoint of that segment. Alright, so then we also have the distance formula. So distance is like we're trying to find the length of the segment using coordinates. So again, we have the same segment we add with midpoint. This was 5, 3, and this was 2, negative 1. So we're trying to find this length. If it was a straight line like one of these, we could just count boxes. So for example, if we had something down here, we could say, oh, this is just 1, 2, it's length 3. But because it's on a diagonal, it makes it a little more difficult. I'm not going to go into too detail of like where this is coming from, just based on what we've already learned. When we get to the point of where you can actually apply it and figure out why the distance formula is the way it is, I will point it out. But the distance formula looks like this. So to get your distance, you subtract the x's squared, and then you subtract the y's squared. And it doesn't matter what order you do. You could go x2 minus x1 squared plus y2 minus y1 squared. You could even, you don't have to have the y2 first. You could have went y1 minus y2 squared. You just have to subtract the y's and subtract the x's. All that's under the square root. And really make sure you follow your order operations to make sure you have the right answer. Alright, so let's do the one we have right here with these two coordinates. So I want to find my distance. It's going to be square root, and everything's under the square root. So this is going to be last. So I have 2 minus 5, and I'm going to square that, plus negative 1 minus 3 squared. Again, the order doesn't matter as long as these are both y's and these are both x's. I'm going to kind of do some math in my head. I have negative 3 here, negative 4 here, negative 3 squared. That's negative 3 times negative 3, so that is 9, plus negative 4. Negative 4 squared is 16. Anytime you square a negative is positive. Add those two together, order operations, square roots last, equals 5. Now you may remember from algebra there's a positive or negative, but distance is always positive, so my answer is 5. And it's 5 units long would be the correct. Everything always have a label. If it doesn't have it, it's usually units. Alright, so here we're going to find the length of RS. So we have 2, 3, and 4, 1. Alright, so plugging into my distance formula, we have the square root of everything, which is last. We're going to go 4 minus 2, take that squared, plus 3 minus 1 squared. 4 minus 2 is 2. Squared is 4. 3 minus 2 is 2. 2 squared is 4. Square root gives me the square root of 8. So then I can type in the square root of 8, which gives me 2.83, and I only need to round to the nearest hundredth. I don't need any more. 2.83 units is the length from here to here. And again, I can kind of look like it's diagonally is usually longer, so it's about 2, so it'll be longer than 2, but if you got something outrageous, then again, using your common sense, very important. This would be a good time to pause the video, try D on your own and see if you can do it, and then check with the video to see if you got the right answer. Alright, so I'm going to subtract my x's. -7 minus 0 squared plus 4 minus 3 squared, which is 1, -7. -7 squared is 49. -7 times -7 plus 1 squared is 1. That gives me square root of 50, which is going to be 7 point something. Type it in. .07 units. That's your final answer. Alright, so you learned 2 formulas here. You learned the midpoint formula, which is adding the x's and averaging them and averaging your y's. Midpoint, middle, so you're finding the middle between 2 numbers or 2 coordinates, and then your distance formula. Yes, you have to memorize these formulas. They're very useful, and they will come out quite a bit when we're dealing with coordinates and trying to find lengths. Alright, just a reminder to do a reflection so you get credit for watching this video.